Hello everyone. So last time we were discussing about this example wherein we declare one class A, we declare a variable x and two methods. One method is to accept the value for x, and display method is to display the value of x. Similarly, in B also we are having one variable y and one method to accept its value and one is to display its value. B is a child class of A. We have inherited class A here in public visibility mode. So all these variables and methods are now available in class B. Okay, so and now we already have discussed that this with same signature we are having here get method as well as display void display. Here also we are having void display. So exactly same methods we are having in derived class as well. So in this situation an inheritance is there. Okay, so when inheritance is there and we are having the methods with the same signature in the derived class, then this is the case of function overriding. Okay, last time I've explained you the difference between function overloading and function overriding. Function overloading, the signature of the function would be different. Like here I may be having some integer a, signature of that function would be different in case of function overloading, whereas function overriding is exactly we are using the same signature here. Okay, here also void gate and here also void gate without any input parameters. So in this case it is called as function overriding. And how these functions will get called, because in class B two instances of you can say two methods with the same name are available. One is through inheritance, I'm having this get as well as display function in class B. One is its own set of function and another set of function through inheritance. Okay, so if it is having two copies of get function and two copies of display function, which function will get called? Okay, so which function will get called here in this case? It depends on what, like here we declare two different objects, one is for class A, another for class B. Now on object a object, if I'm calling this get method or a display method, so which function will get called? The function which belongs to A class. Okay, and when I'm calling this get and display function on B object, it will call the functions from B class. How the compiler resolves it? The compiler resolves it based on the object on which you are calling that function. This A object, what is the data type of A object? It is A, so it will call this get function from A class. Whereas for B object, what is the data type? It is B. So whenever I'm calling this function on B object, it will call the get function from B object. Okay, so how how the compiler is resolving this ambiguous situation? Because for A we have seen that only one copy of get and display is there, because A is a base class. Okay, only one copy is there. But whereas in B, through inheritance, one more copy of get and display is available along with its own set of get and display. Okay, so in case of B, here only there is a situation of ambiguity. So how this ambiguity is resolved? It is resolved based on the type of this object. Okay, if this object is of type A, then in that case it will call the function from A, and if it is B, then it will call the function from class B. Okay, so this is the case of function overriding. Okay, now in the same example I will add now pointer concept. Last time we have discussed about pointers also. So now here, if I add the concept of pointer, now let us name this pointer as A pointer. Okay, and similarly we'll have one more pointer called B pointer, right? So now instead of object, if I try to call the functions on pointer, okay, say let us say first we'll use this A pointer and make it point to A object, right? So A pointer is pointing to A object. How to call these functions now? On pointer, and then I need to use arrow here because this is pointer, so I cannot use dot here. So this is pointer and I'm using arrow. Similarly for B object also. So B pointer will start pointing now to B object. And now with the help of this B pointer, I want to access this get method. Is it possible? Yes. Using pointer, how to access, we'll see it now. So using pointers also, we can access the methods. So this is B pointer and then arrow. So if it is pointer, using pointer also we can access these method, and same concept will be applicable of function overriding. Let us execute this program and see whether it is working as per our expectation. So yes, first time we are calling it on which pointer? A pointer. So it is calling the get function for x. It is asking me for x value. Okay, so I'll enter, say for example 10. Now the next thing is display. Okay, so it should call the display from function from a pointer, and after that it has to call the get method from b. Okay, so it should ask me, get method from b means what? It should ask me to enter the value of y and not x. Okay, so let us see whether it is yes, it is working perfectly. Enter y, so it is asking me to enter the value for y only. So again displaying the value of y. So now also it is working perfectly. Like if I'm calling this get function on this a pointer, it is calling the get and display from a, and similarly here also it is calling it from b. So in this case also it is working perfectly all right. The reason is again same thing. How it is resolved? It is resolved on this only. Yeah, now this get function I am calling on a pointer, so it will call it from a, and in this case this get function I am calling from b pointer, so again it will call it from b class. Now again we'll try to make, because see here inheritance is there, so these two classes are related, class a and class b, these two classes are related. So can we make one a pointer of class a to point to class b, and similarly can we make a pointer of b to point to class a, because these two classes are related through inheritance. So can we make those pointer to point to other class? Like can a parent pointer point to a child class, and similarly can a child pointer point to a parent class? So whether it is possible or not, first let us see that. So here first what I'm doing, I have created pointer to a. Okay, and this a pointer, whether it is possible to make this a pointer to point to b object or not. Okay, so that is what we want to test. So I'll make this a pointer point to b class. Okay, so whether it is possible or not, the base class pointer, can it hold the object of the derived class? So let us test that first. Yes, it is allowed. Okay, so base class can point, the pointer of the base class can point to the object of the derived class. Okay, now in this case which function it is calling actually? Which function it is calling? It is calling get function from on a pointer. Okay, from which class it is calling this get function? It is asking me to enter the value of x. That means it is calling it from, it is calling it from class E. Okay, but here actually what you are expecting, what you are expecting that now at this moment in time this a pointer is pointing where? It is pointing to b. So ideally if it is pointing to b, it is supposed to call the function from b, right? Na? At this moment in time, if this base pointer is pointing to the derived class, it should call these method from the derived class, because its job is to point to the derived class, so it should call it from the derived class. But it is not happening. Why? Because compiler is resolving it. Early binding is taking place. Early binding is compile time binding. Compiler is taking the decision on this. How compiler is taking the decision? Like this get function we are calling on a pointer, and what is the data type of a pointer? A pointer is of type a, so it will call the function from a. But do we want it now? No. What we have done, we made this a pointer to point to the derived object. So at this moment in time, my expectation is this get function should not be called from A. It should call this get function from B class, because now at this moment in time, it is pointing to B class. Very clear. It is pointing to B class, so it should call this get and display function from B class. But is it doing so? No, it is not doing so, because it is asking me to enter the value of X, whereas it should ask me to enter the value of Y, because this belongs to class B. It should call get function from B. So it is not working in the manner that I want it to work. It should actually, at this moment in time, it is pointing to B, so it should call this function from B. Yes, this is the expectation. This is my expectation as a programmer. Now, in this case, it is not happening because compile time or early binding is taking place. In case of function overriding also, early binding is taking place. The compiler is taking the decision based on the data type of this. Okay. Now, I don't want this. I want to make it as a late binding. Late binding matlab at the time of execution. At the time, why I want it at the time of execution? The reason is that if this A pointer, if this base pointer is pointing to class B, so in that case, it should call this get and display function from class B. So it is not based on the data type of this A pointer, but it should be based on which value it is holding at that moment in time. If it is holding the address of B object, then it should call this function from B object. And if it is holding the value or the address of the B object, it should call it from B. A, sorry. If based on this, if it is pointing to A object, it should call it from A. And if it is pointing to B object, it should call it from B object. Okay. So it is based on the value that it is holding at runtime, and that is the reason I want to postpone this binding to execution time. I don't want the compiler to take this decision in the early phase. I want the compiler to take this decision at runtime or at the time of execution. Based on what? Based on which address it is pointing, which object it is pointing at that moment in time. Okay. So now this same pointer, if I use here, same A pointer, and make it point to A object. Okay. So here also I'll use A pointer only. Okay. So this A pointer only I'm using first. In the first iteration, what I'm doing, I'm making it pointing to B object. In the second iteration, I'm making it to point to A object. Okay. So here my expectation is it should call this get and display from which object? From this, because now it is pointing to B. Similarly, this get and display function, now at this moment in time, it is pointing to A. So it should call it from this A object. Okay, so this is my expectation. Now let us see whether it is working in that manner. So first, what you should get? First, you should get from which class? B class. So it should ask me for Y value first. Okay, so now just I'll go ahead with this. Just a moment, and we'll re-execute it. We will re-execute this program. So first, now my expectation was it should first ask me for Y, because at this moment in time it is pointing to B object. But is it asking to enter Y? No, it is not asking. It is asking me X only. Again, it is asking for X value only. So at both the get for both of these code snippet, we can say it is calling function get function and display function from A class only. Okay, so again it is compile time binding. It is calling it from A. So compile time binding means what? It is depending on the data type of this. Okay, so data type of A pointer is always A. So it is in both the cases it is calling the function from A. But I don't want this. As a programmer, what I want, the decision should be taken at runtime. Whenever this A pointer is pointing to B, it should call it from B. So first it should ask me to enter the value of Y. Okay. So if this is my expectation, if I'm expecting a late binding, okay, binding means what? This function call, for this particular function call, which function definition is to be called, whether it should call this get function or this get function. Okay, so what I want, this binding process should be done at execution time, which is called as late binding. Okay, are also called as runtime binding, execution time binding, or it is also called as runtime polymorphism. Okay. So, or dynamic polymorphism. So if I want the dynamic polymorphism or runtime this decision to be taken, so how is it possible? Just by adding a virtual keyword in front of these two functions. So by making these two functions as virtual, what I'm saying, I'm requesting a compiler to resolve this function call at the time of execution. Okay, at the time of execution, that means the runtime or late binding to take place. Okay, so in this situation, like here, when I make it virtual, okay, when I make it virtual, I'm requesting the compiler that do not take the decision based on the data type of a pointer. Yes, if it takes the decision based on the data type of a pointer, then it will be always compile time binding. Okay, early decision. I'm requesting the compiler to take the decision based on what value it is holding at that moment in time. If it is holding the address of B object, it should call it from B. And if it is holding the same pointer now, but now it is holding the address of A, so it should call the get function or display function from class A. Okay, so it will be based on the value that it is holding at this moment in time. Okay, and not on its data type. So let us see whether it is asking to enter y value first. Okay, yes, it is asking y value to enter first. So now this decision is taken based on the value that is it is holding. Okay, so if it is holding the address of B object, okay, it is calling this get and display function from B. So let us enter the value for y, 10, and now it is displaying the value of 10. So this get and display function is called from which class? B class. Okay, because this data type is sorry, this object is of type B. Now same pointer I'm using, a pointer only, but now at this moment in time it is pointing to a object. So now it should call get and display from a. So it should ask me for x. Is it asking? Yes, it is asking for a value. So let us enter 30 maybe. So it is displaying the value of x on the screen. Okay, so now this decision is not taken by the compiler at compile time based on the data type of a. See here, if you observe, data type of a pointer is same here also and here also, but here it is calling the get function from B object, whereas this get function it is calling from which object? A object. Okay, so it is not resolved on the type of this pointer, but it is resolved on which address it is holding at this moment in time. Okay, so this type of binding is called as late binding. This is called as what? Late binding. Okay, and this late binding process is called as dynamic polymorphism, right? Okay, so this late binding is called as dynamic polymorphism. Okay, so we have executed it also, and we have seen that yes, it is working perfectly just by adding this virtual keyword in front of those overridden methods. Okay, in the base class, only in the base class you need to add this virtual keyword, not in the derived class. Simply by adding it virtual here and here, what we are saying, we are requesting a compiler to go for late binding. Okay, we are requesting a compiler to go for late binding here, that is, do not bind this function call based on the data type of this pointer, but but make this decision based on which address it is pointing at that moment in time. Okay, so this is about runtime polymorphism. Okay, so this is about runtime polymorphism. Thank you everyone for attending this session. Thank you.